Next presentation is Wi-Fi positioning system on the Android platform. This is the first of the senior design Tuesdays.
Good afternoon. Thank you all for coming. My name is Michael Howell, and I, along with the design team of Staley Allen, Drew Choi, and AndroidTM, have spent the past 2 semesters developing an indoor positioning system using Wi-Fi signal strength and trilateration. We've had a number of successes and a few failures along the way. I'm here to discuss those with you. To begin, our principal success was building a simple Wi-Fi sniffer that would detect all of the accessible access points within the building at our command and display. Initially, it would just display the strongest signal. We then modified this so that it would pick out selectively our access points within a test environment, display their IDs and their signal strengths, which we then used to collect about 1,000 measurements. Actually, I believe it was closer to 1,500 to 2,000 measurements, which we would use to approximate our distance. Skipping forward a bit, distance being our stumbling block. Once we had a distance, we could feed the distance to an access point and the locations of 3 access points to a trilateration algorithm, which would determine a position, 2 positions actually, 2 points of intersection between 3 spheres, and display that to the user. As we kept the z-coordinate of our access points constant, we were able to use this to pick 1 position in space. Trilateration, therefore, was sufficient to position a user within 2 dimensions. Third dimension was taken to be the floor on which we found our access points. Once a position was determined, we were able to show that position on a map on an Android tablet. We kept that fairly straightforward, just picked a point, one of predefined points, and would display that depending on the range in which our distance was calculated. Distance. Distance approximation based on our SSI measurements is, in theory, is found using that logarithmic function shown on our slide. Our experimental data, however, did not quite support that. We had a logarithmic function, which you may be able to read there on the slide, that showed a fairly high correlation with our data. However, it did not result in anything that we could use predictably enough to calculate a position. At our best, we were able to approximate a distance between approximately 0.2 meters off of a known location, but that would vary up to about 5 meters off. We saw virtually no change in signal strength between distances of 5 and 15 meters from an access point. Within that range, our approximation would always come out to be about 6.8 meters, which is handy if you're always 6.8 meters from an access point, but otherwise does us very little good. So, in summary, we have this solution, all of which works beautifully except for 1 stumbling block, which renders the whole thing unusable. I hate to say it, but that's where we are. I'd like to thank Bailey for his efforts to make sense of our distance calculations, Yoon for her Android expertise, and Yoongjun for coordinating our testing. It's been a pleasure. Thank you for listening. Please stop by to see our poster. Welcome any questions.
So, somewhere back in there, you said something about giving the Z, assuming you're on the floor once you found the access point. If I'm walking down the hall here,
Right.
I may pick up an access point that's on the floor above or below me.
Exactly.
Which is closer than the one that's down the hall.
Right. And that was our initial intention, to pick access points within the building and use them to calculate a position. We could use 4 points to fix a position uniquely in 3-dimensional space. We had all that worked out. However, we found some stumbling blocks, and so we minimized our problem. We decided to build our own test environments. We controlled all variables we could, and therefore we knew we'd be on that floor. So we simplified the problem as much as we could, and we still weren't able to get a working solution.
I was going to ask what happens if you don't have 3 points, but I mean, you don't get the right number anyway. Who cares?
Exactly. Right. We tested using dual bound routers. We had 2.4 gigahertz signals, we had 5 gigahertz signals. We knew our locations in space, and as you can see, we saw that curve that would just kind of level out from 5 to 15 meters, regardless of which band we used, where we tested. We went around corners, we used open space. Due to multipath propagation or environmental concerns, it just wasn't usable.
2022, you set a challenge, you wanted to create a positioning system based on Wi-Fi. You decided, presumably during city design 1, to use the triangulation method.
Trilateration, yes.
Now, you now having completed this, think that was the right approach.
It's a difficult question. The trilateration portion of the program works as designed. It works beautifully. The distance calculation was always the stumbling block. We knew that going in. The goal of the project from the beginning was to try to make a solution that used off-the-shelf components. So that precluded us from using more advanced methods like time difference of arrival, and other things that depended on precise timing between transmitter and receiver. It also precluded us from knowing some of the physical properties of the transmitter and the receiver. So it was really a function of our project scope was to use as little information as possible to limit us to this approach.
At what point during the semester did you realize that you weren't getting the right answer? I mean, last week, was it a month ago, 2 months ago?
Again, we knew going in it was going to be a problem. Within the last 2 weeks, we thought we would be able to come up with a solution within about 2 or 3 years, which we thought might be suitable for this project. But even within the last week or so, we got data that was all over the map.
Because realistically, there is commercial Wi-Fi mapping software that's available that runs on a PC, it uses regular off-the-shelf components, you don't put special cards into it.
They don't use distance and trilateration to calculate position. Most of them use...
Exactly my point.
Right.
Did you pick the right technology for the engineering problem?
Our goal was to make a...
One of those out there uses like the nearest point type algorithms. If you're close to that, it's within 500.
I'm talking about commercial software that would come through a building like this, and it would map your location accurately to within about a foot. And it uses a lot more than 3 access points to raise the cache.
And our initial plan was to use all of the access points within this building. And we had a map of this building, we had the locations of all the access points, we had the MAC addresses of the access points, we could identify the access points. Most of those applications will either fix you near the strongest signal and just assume that the strongest signal is more or less the closest access point, which is sometimes true, sometimes not. Or they will map all of the wireless signals within an environment, store that in a table, and look up in the table. They say, okay, your device at this location can see XYZ wireless signals, therefore fit you at that position. The problem with that approach is that if one of those signals goes down, if the temperature changes, if anything else changes, that entire map has to be redone. It's time-consuming to remap the building. Our approach, if it worked, which sadly does not, would have been more readily implemented and more readily updated, and therefore would be suitable for, say, fire rescue or other environments where you're going in and you don't necessarily have the time to map a building. You just know physical locations.
I know we're out of time, John, so I'll just make the comment that I'll make is you guys do clearly understand what you were trying to achieve as a set of objectives. And so the fact that you kind of failed at the end of the project is not as important as the fact that you had clear objectives and you went and tried out and unfortunately you ran out of time.
Right.
You know, at least you stood up there and admitted it didn't work. So,
We considered briefly setting up a tablet that would just kind of rotate the little device in a 4-loop and try to shine